This time on Battle Factory. The scope that's right on target from 2.5 kilometers away. An airborne supply system that delivers the goods from 9 kilometers up. These boots are made for marching. And one of the most imitated handguns ever made. Battle Factory steps beyond the front lines into top secret factories where combat gear is built for battle. This aluminum block will soon hold a piece of ground glass that has the power to extend a sharpshooter's eye, so he can see, stalk, and connect with a target that's kilometers away. The rifle scope is small, lightweight, and has a revolutionary fog-proof lens, so the glass will not fog up no matter what the weather. The sophisticated rifle scope began in the 17th century as a set of crosshairs, actually made from human hair or spider webbing, and mounted on the tip of a rifle barrel. But today, with advances in rifle and scope technology, elite snipers have made record shots at seemingly impossible distances, up to 2.5 kilometers from their target. The loopholed rifle scope breaks down into the lenses, the erector system, and the main body. The body starts as 3.7 meters of aluminum tubing. The blanks are placed in a computer-controlled cutting machine where they rotate on a spindle. First, the eyepiece end is cut. Then, the objective end, the side that faces the target, is machined. Rifle scopes have 3 main sections that magnify an image: the objective lens, the internal erector lenses, and the ocular lens. As the light passes through the series of lenses, the image starts upside down and is then flipped back before being magnified. Next, the erector system of the scope is machined. The pivot tube, which will hold the internal lenses, and the cam tube, which slides over top and controls the movement of the lenses back and forth. Next, the eye shell and lens holder is machined and washed. Finally, mounting rings are cut. These will fasten the scope to the rifle barrel. The rings are then stamped with a logo and set aside for coating. Next, it's sandblasted to prep the body to be anodized, a chemical treatment that coats and protects the aluminum. During the Vietnam War, the legendary American sharpshooter, Carlos Whitefeather Hathcock, became one of the Viet Cong's most feared snipers. An equally lethal Vietnamese sniper known as the Cobra was enlisted to take him out. Meanwhile, Hathcock was tracking the Cobra. While stalking his adversary, Hathcock caught a momentary glint in the undergrowth and fired at the reflection. He sent a bullet directly through his enemy's scope, killing the Cobra. Later, Hathcock realized the only way he could have made the shot was if he and the Cobra had been looking directly through their scopes at each other at the exact same moment. Lucky for him, Hathcock fired first. After being anodized, the scope is now a matte black. All the anodized parts are placed in a carrier basket and ferried through a series of tanks containing detergents and cleansers that prep them for a 100% sterile environment. In a clean room, the eyepiece is assembled. Then, the rings are glued together and the ocular lens is dropped onto the eyepiece. Then, the erector system is assembled and the main tube is put together. Once the scope is fully assembled, it is calibrated to make sure the optics and mechanics line up perfectly. When a sniper is taking aim, he may not be putting his target in the crosshairs, but adjusting his scope to compensate for distance, temperature, and wind velocity. The scopes are then inserted onto blocks, and a tiny piston shoots inert gas into the main tube. This will prevent fogging in the field no matter what the temperature or humidity. Then the scopes are fitted onto a carousel and put through the dunk test. If any bubbles are visible, that means there's a leak. Finally, the adjuster tubes are added for wind variation, elevation, and focus. The scope sits securely on the rifle barrel. The shooter squints through it, putting his target in the crosshairs, making minuscule adjustments. This refined melding of precision optics and crafted mechanics all come down to one moment and one shot. Coming up on Battle Factory, the airborne care package that can find its own way to the drop zone, and military footwear from boot camp to the battlefield. When they're packed up, these containers will be giant care packages, bringing airborne aid that can make the difference between help and being helplessly stranded. And not only can they fly, they can get there on their own. Precision Aerial Delivery System, or PADS, are guided by GPS. Computer coordinates program the airdrop, and built-in motors using pulley systems steer the package for up to 15 kilometers, transporting loads of supplies and landing within 100 meters of the drop zone. While the military had been dropping bombs out of the sky since World War I, it was only in the Second World War that they began using their planes to airdrop food, medicine, or weapons to soldiers operating deep behind enemy lines. But these airdrops were hit and miss. Packages often landed kilometers away from their targets. Today, NATO considers precision airdrops among its top priorities for humanitarian aid and defense against terrorism. The Sherpa model breaks down into the parachute, the payload, and the guidance unit. The black box, called the Aerial Guidance Unit, consists of two small metal compartments that fit together. The first step is to assemble the upper half, or the muscle of the guidance unit, which contains the basic driving mechanisms and pulley system. The pulley system will tug on the parafoil's lines to steer the Sherpa to its drop zone. The lower half is the brains of the unit. It houses the GPS software that can track where it is and where it's headed. A stack of computer cards receives location information from the GPS receiver. It computes a flight path to the target point and instructs the parachute when to open. The onboard receiver means that the unit can also be controlled using a remote control. A battery is installed and the two halves are assembled. Now, the aerial guidance unit is ready for rigorous testing. If the drop is from 9 kilometers over the desert, the temperature starts at a freezing 50 below, then soars to plus 40 as it lands on the burning sand. So the pad's computer and mechanics are tested at extreme temperatures. The parafoil lines are connected to the AGU, and under simulated flight conditions, the steering mechanism is stressed to its limits. When it's passed the test, it's ready to be connected to the parachute. The parafoil is what makes the Sherpa fly. It's made from double layers of super strong parachute material called ripstop nylon. Once it's sewn together, every centimeter of the material is checked. Even the tiniest nick could shear it and bring a huge payload crashing down. When the space between the two layers of chute material fills with air, the parafoil becomes a rigid rectangle, like the aerodynamic wing of an airplane. A Sherpa can have up to 100 suspension lines made of very strong nylon, which is built to hold 10 times the weight of their designated payload. Once the lines have been methodically organized and laid out, the chute is packed into a bag. 2004 was the first time a GPS-guided PADS was used. A U.S. headquarters in western Iraq that was home to a hospital and Marine garrison was at risk of heavy insurgent attack. The only way to get the much-needed supplies was from the air. Deployed from high above enemy detection, the newly developed PADS floated downward and steered itself to the correct coordinates. The food and medical supplies landed safely in the camp. The final step is to integrate the guidance unit and the parafoil. The PADS has the brawn to deliver 4,500 kilo care packages to their destination and the brains to get there on its own. Coming up on Battle Factory, the boots that form a soldier's footsteps, and the world's most popular pistol. When these strips of leather are cut and cobbled together, they'll march a Marine through a life of service. The Army boot is a symbol of military life that takes the soldier from the parade ground to the battlefield, but they aren't all created equal. The Danner rugged all-terrain boot is built to keep the U.S. Marine warm, dry, and protected, whether he's trudging through a desert or slogging through swamp. But it's been a long haul getting here. The trench boot took its first steps during World War I in the cold, wet mud of Europe's Western Front. Made from rough-cut leather with hobnail soles for additional traction, the boots were coated with wax dubbin to waterproof them against the persistent damp and the threat of trench foot, a disease that caused a soldier's feet to literally rot in their boots. But the coating wasn't enough, and 75,000 troops succumbed to trench foot. As military theaters changed, design of the military boot had to evolve along with it. The Danner all-terrain boot breaks down into the liner, the sole, and the exterior. The first step is to check the leather for quality and strength. Then the hides go to the leather cutting station. Steel dies cut out the patterns that will form the outside of the boot. The leather is then stamped with the official insignia of the United States Marine Corps. An automated sewing machine double stitches the boot's leather quartered panel with extremely strong nylon thread. Then the rest of the pattern is hand sewn to complete the side panel, which will keep the ankle dry and protected. 12 eyelets are punched out for laces, and then the side panel of the boot is sewn together. Once the excess leather is trimmed, the exterior of the boot is complete. Using dies that look a little like Christmas stockings, the boot liner is cut out of waterproof, breathable Gore-Tex. The pleated halves are stitched together using a surging stitch that can easily accommodate the curved shape of the liner. The booties are then inflated with air and dunked into a water tank to check for holes. Bubbles indicate a leak, which means they are either repaired or thrown away. These Gore-Tex liners ensure that the boots can tramp through ankle-deep water without getting the soldier's feet wet, making the boots 100% waterproof. The boot is ready to be put together. First, hooks are added for speed laces, just like on ice skates. The lining is stretched into shape on a plastic foot mold. A felt insole board is coated with glue and pressed onto the bottom of the lining. The top layer of the boot is glued on, and the leather is stretched right over the toe. The boots and rubber sole are heated to over 90 degrees Celsius to activate the adhesive. A tack clamps the boot and sole together to complete the watertight seal. First, they test the sole's bond to the boot bottom. It takes almost 115 kilos of force before the sole gives way. The laces and eyelets are jerked around over 15,000 times and still refuse to stretch or tear. Then the boots are dunked in water and flexed 100,000 times to simulate a tour in swampy terrain. Life is tough enough for a Marine without worrying about what's underfoot. The right pair of boots isn't just part of the uniform. They're as critical to a soldier's survival as their weapon. Coming up on Battle Factory, a straight shooter that aims for accuracy. These bits of steel and spring and coated plastic will pack into a pistol that's one of the most popular sidearms ever produced. Designed in the Czech Republic, the CZ75 9mm pistol was first designed in 1975 behind the Iron Curtain. Its firepower and accuracy became legendary and has since been imitated by manufacturers around the world. Today, the CZ75 is the default sidearm for a long list of police and military forces. The pistol breaks down into 4 parts: the frame, the recoil spring, the barrel, and the slide. Every time the pistol is fired, recoil slams the slide back and pops out the spent shell. Then a spring bounces the slide forward, chambering a new bullet as it returns to firing position. The slide starts out as a piece of raw steel. A robotic arm grabs it and puts it into a computer-controlled cutting machine. The machine then carves out the basic shape. Automatically selecting from a series of cutting tools and drills, the machine further refines the slide, rounding the edges and cutting out an ejector hole to jettison the spent cartridges. Every member of the U.S. Special Forces, like the legendary Delta Force, is armed with a pistol. When a Black Hawk helicopter was shot down in Mogadishu, Somalia, 2 Special Forces snipers insisted on being airdropped into the fray in order to defend the wounded crew under siege by a mob of Somalian insurgents. Armed with only their sniper rifles and pistols, they established a perimeter to protect the wounded crew. The first soldier was killed, and the second stepped directly into the line of fire, holding them off with just his pistol until the very end. For the first time since the Vietnam War, both brave soldiers were posthumously awarded the Medal of Honor. The barrels of the CZ75 arrive coated in rust. They're actually left outside during the changing seasons to be weather cured, which toughens the metal, a CZ family recipe. The barrel is made from a special alloyed steel, heat treated for hardness. Holes are bored through the center, 4 barrels at a time. Then the rusty outer bark is scraped off. The barrels are placed in a cold hammer forge. 4 hammers pound on the barrel at 1,000 hits per minute with 10 tons of pressure to stretch and toughen the steel. During this hammering process, a spiral-shaped tool forms corkscrew grooves on the inside walls, called rifling. When the bullet is fired, the rifling causes it to spin, which makes it fly straight and aim true. Then the rifling is inspected and the interior of the barrel is cleaned. The frame is made from a super-strength polymer reinforced with fiberglass. The spring absorbs the energy of the recoil and protects the frame from the impact of the slide. Every time the pistol is fired, the recoil sends the slide back into firing position, chambering a new round as it goes. Finally, the slide and barrel are joined with the frame. The gun is complete and ready for testing. Every CZ pistol is strong enough to be dropped from 4 meters with a round in the chamber onto a concrete surface. It will hold together, and the coated polymer frame won't crack under impact. Finally, the gun is loaded up and lit up at the firing range. Since its inception in 1975, there have been literally thousands of imitators of the CZ handgun. But whether it's on the firing range or the combat zone, when you need to give it your best shot, you want to reach for the real thing.